Okay, well, welcome to the last video for the moment on SQL querying, and the topic for this video is views. Views are a useful structure in database systems and serve effectively two useful purposes. What a view is basically giving a name to a query. You can use that to either have a named report. So you write a query that effectively gives you a list of information, and you give it a name, and then you can invoke it by name anytime you feel like getting that information again, rather than having to type the query in. The other use for views is that they effectively form virtual tables. So they're things that look like tables, and in fact they'll show up if you type \D to PSQL. It'll show you views and tables in the same output, because both views and tables are things that have a name and a list of attributes, so they're quite similar. But a view is different in the fact that it's based on a query and is computed each time based on the current state of the database. Of course, a table maintains the current state of the database. Okay, so we're going to use the football database once more and take a look at a couple of the examples we had in the previous video and show how they can be done as views. Okay, so the first one was representing players and the number of goals that they had scored. And I will jump straight into the editor and all that. And here's one I prepared earlier. So here's the definition of the query that describes players and the number of goals they scored, which we made up last time. And this is wrapped up in a view. Okay, so the name of the view is player goals. We're creating the view, and in case the view already exists, we add this extra clause which says we'll either create the view if it doesn't exist, or we'll replace it if it does exist. Now, create or replace is fine if you're modifying a view without changing its interface, if you like. As soon as you change the attributes, you have to drop the original view and create the new view separately. Okay, so this will create a view. Let's just do it, and all that Postgres tells us is that it's created a view. To actually use a view, we use it in much the same way as we use a table. Player goals. So this gives us a list of players plus all of the goals that they've scored. And to emphasize the point that it's a little bit like a table, we can do things like order by number of goals descending to get the high scoring players, which we saw before. Or you could use a where clause and get goals just by a particular player. So we can see that that player scored 3 goals. Okay, so let's take a look at creating or replacing the view again. So let's go back to the view. Notice that we've created the attribute names for the view using as clauses in the select clause, using as statements in the select clause. But we can equally well do it by giving the names of the attributes associated with the view name. So I do it like this, and this is how I'm going to do my views from now on. So you don't need the as clause here. Basically what this is saying, make a view called player goals, which has 2 attributes, player and goals, and what you ought to have is two values that are being produced here. So I should be able to do that and get the same set of results as before. So I've recreated the view but in slightly different form. So as I said, the views from now on I'm going to make using that format there. Alright, so that's it for players and their goals. Let's take a look at the next task for review, list of matches. Now you may remember that I solved this in the previous SQL query video. Ooh. And let's jump in here and grab this view. Okay, so hopefully this looks familiar from the previous video. If you haven't watched the previous video, you should have. So remember that we're trying to form a bunch of tuples that give you the name of the two teams involved in a match, the city where the match is played, and when it was played. Okay, so these attributes here are derived from these actual attributes. So the country name for T1, country name for T2, the city for the from the match, and played on from the match, which gives the date that the match was played on. And if you remember how we did this, we've got a single match which has to join with two teams to get the two team names, and we had to do it using this five-way join, where we joined against the involved relationship twice, and from the two different involved tuples we joined with the teams. Now if we didn't have this where clause, you might remember from the previous example that we'd get all the different combinations of teams in team names from the same match. So if it was a Brazil-Argentina match, we'd get Argentina-Argentina, Brazil-Brazil, Brazil-Argentina, Argentina-Brazil. So this where clause effectively limits it to just one tuple. Alright, so with any luck that won't have any syntax errors, and we can create that view and then start looking at match info. Okay, so we can see team 1, team 2, the city where the match was played and when it was played. So given this, we could then start to ask queries about matches, forgetting how this table was produced and just treating it as a high level object. So let's say we're interested in all the matches that were played in Madrid. So we can ask a query, a relatively straightforward query, to do that. Okay, if we had to reproduce that complex query each time, that would be slightly annoying. Or if we wanted to find all the matches that Argentina had played in, that's slightly tricky. Note, I won't choose Argentina, I'll choose Brazil. So we need to take account of where Brazil occurs either as team 1 in the match, or where it's team 2. So this will give us all matches that include Brazil. So we've got matches where Brazil is first and matches where Brazil is second. And so Brazil is played in 24 matches. Okay, so you can use, once you've created the matches info, you can use it for a number of different tasks, and it effectively hides that complex query. Okay, now at the end of the previous video, I suggested another query which looks kind of similar. It's got teams, the place where the match was played, and the date it was played, but now I have to include the goals. if you do that, the query becomes even more complex than it was before. And so I decided to show you how you might solve this query by breaking it up into a bunch of simple joins and putting those joins together to give you the final result. So each of the joins gradually moves you towards the final result, and at the end you can produce the final result with a relatively simple query. So let's have a look. So I've got all of these views defined in a file, and I think I might actually start at the bottom. So the final thing we want is a view match stats, which is going to give us the location where the match is played, the date it was played, the first team, the number of goals the first team scored, the second team, and the number of goals that the second team scored. Okay, to get there, all right, well, relatively straightforward. I've got a join with match and an object called match scores. Now, in this context, it kind of looks like a table, but match scores is actually a place where we've collected together information about the number of goals that individual teams have scored in a match. And so it makes it quite easy to run this query. So all we're doing in this final query is we're picking up the name of the place where the match was played, and we're picking up the date information and putting that together with information that we've already accumulated in the match scores view. Okay, so let's go up to the match scores view, which is this one here. So the match scores view has a match ID and the name of the team, number of goals the team scored, name of the second team, number of goals that the team scored. So this is almost what we need to solve the final query, but we're just not bothering to do the extra join to fill in the information about the match. We're saving that to the final view. Okay, so this view here basically takes information from something called team scores, joins team scores with itself, and basically what we're doing here, we're grabbing the scores from the two different teams from the same match and creating a tuple that combines those. So we end up with the match information and the team and name and goals from the match. Okay, so how do we get team scores? So each team scores tuple is going to have a match and a team and the number of goals that it scores. Okay, so match, team or country, and the number of goals that were scored. Okay, how do we get that? Now this is complicated slightly by the fact that a team might not score in a match, and so we need to make sure that the team gets included even though it was in the match but didn't score a goal. So we've got another view that will tell us what teams are actually in the match, and we can do a left outer join to make sure that all teams are included, and then join against the goals that each individual team scored in the match. Now it's possible, given the left outer join, that the number of goals might actually be null if there are no goals scored by a particular team. So we have to introduce another mechanism that Postgres provides, and most other databases provide a similar mechanism. Basically what this function does, it checks whether the first argument is a null, and if it is, it replaces it by the second argument. If it's not a null, then the value of this whole function call becomes the value of the first argument. So working out what are the teams in the match, working out how many goals each team scored in the match, putting those two things together. If they did score any goals, they'll get a null for the number of goals, and we convert that to a 0. Otherwise, we keep however many goals they scored. So finally, that gives us a view that tells us in this particular match, this country scored this many goals. Okay, so we've still got to worry about teams in match and goals by team in match. All right, so what are the team, tying together the team information and the match information? Well, we use the involved tuple and the team tuple, where this particular team is involved in this particular match. And basically what we're doing here is we're picking up the team name, but we're also maintaining the match ID and the team ID. We could equally well have used t.id for this second attribute. Okay, so that's a really simple view, that one. We could have easily come up with that ourselves. And in fact, all of these views are relatively straightforward, and they all involve a single join. So if you can understand a single join, you can come up with all of these views. Now the final one is how many goals were scored by a particular team in a particular match. And I think we saw roughly how we could go about solving that problem in one of the previous videos, but basically we've got goals and we've got players. Now we don't directly have which team scored a goal. The way we have to work that out is by going to the goal, working out which players scored it, and then working out which team they're a member of. Okay, so once again, we don't need to collect symbolic information. What we're going to collect is simply the match ID, and notice that we simply use the scored in attribute from the goal table, so we don't have to do a join with the match table. And similarly, once we've got to the player table, we've got the team ID for the team that they're a member of, so we just grab that. So it's a relatively straightforward join, and joining the player table with the goal scored by table, and using the information from that join, we can come up with those three attributes. So that's how we can construct. So starting from these very simple bottom level views, we can put them together and gradually build up to solve quite a complex problem. But the solution step is itself relatively simple, because we've managed to get all of the information together in other views. So let's take a look just to convince you that this actually works. Now there are plenty of different ways that you could write that view, or write the solution to that. You could do some of the additional joins and have less intermediate views, but I decided to keep it really simple and keep each view with just a single join. Okay, so the whole goal here was to have a view called match stats that would tell us teams, goals and locations. So in Rio de Janeiro on the 1st of May 2000, Brazil scored 0, China scored 0, so it was a 0-0 draw. In Shanghai we had China beating England 2-1, seems unlikely, but there you go. In Sydney we had Australia beating England 3-1, also seems unlikely. In Seoul in 2004, Australia beat Korea 4-0, also seems unlikely. But regardless of the realism of the data in the tables, this view has managed to produce a collection of information that we requested. Okay, so views are a very important structuring mechanism. In some ways, they're almost analogous to functions in a programming language. So they allow you to abstract things, package them up, and then reuse them in different contexts. Okay, so that'll do for this video.